us are not following instructions. It says write the equation of the tangent line. So first you need a point. So 2, and where's the function? Y. So if you plug in 2, you get 10 over 5, which is 2. And then you need the derivative for the slope. So since it's a quotient, low, d high minus high, d low, all over denominator squared we go. And then I wouldn't even bother simplifying it, I would just plug in the number already. So what would that be? 5 times 3, 15. So if you plug into 10 times 4 is 40, all over 5 squared, 25. So that comes out to negative 25 over 25, which is negative 1. So just do point slope form. Look. And just leave it. Some of you are still trying to put it into y equal mx plus b form. Don't do it. You're going to find out in a couple chapters why this form is going to be superior. Number 2, compute the value of the derivative of u times v when x is 1. So, since this is a product, you use the product rule. Derivative of the first, leave the second one alone. Leave the first one alone, derivative of the second, and then you just simply plug in 1 and look at the values. So u prime of 1 is negative 4, v of 1 is 5, u of 1 is 3, v prime of 1 is 2. So what is that? Negative 20 plus 6 is negative 14. Kajuga. Number 3. Isn't this like the exact same problem on the homework, or did I change it?
I think he switched the plus and minus.
Oh, is that all he did? Okay. So since this is a quotient, you need to use the quotient rule. Low, d high, so that's 1/2 x to the negative half, right? Because that's the same thing as x to the half. Minus high, d low, 1/2 x to the negative half, all over denominator squared we go. Now you need to simplify. Well, since this and this are common, factor it out. And then what's going to be left? Don't forget to distribute that minus sign there. And then these cancel out. And then 1 plus 1 is 2. But doesn't that 2 cancel this 2? So your final answer will be 1 over root x plus 1 squared. Right, because x to the negative half means square root of x in the denominator. Oh, number 4, this is one of the worst problems on the quiz. Look, as soon as you see this, and you don't even have to look at the rest. Once you see this, this is the definition of the derivative. Okay? So, you've got the 4th root of 16 plus h minus the 4th root of 16 all over h. So this is equal to f prime of 16. See, if there was an x here, then it would be f prime of x. But it's not. Okay, you know what? Maybe it's easier to do this. Look. Think of it as an x there. That's the definition of the derivative. What function are you taking the derivative of? This. This is f of x. And isn't that x to the 1/4 power? Okay, so what's the derivative of x to the 1/4 power? 1/4 x to the negative 3/4. But there wasn't an x there. There was a 16 there. So that means you need to plug 16 into the derivative. So your answer is 1/4 times 16 to the negative 3/4. That's the answer. But you need to simplify it. So this is 1 over 16 to the 3/4. So you 4th root it, 2, and then cube it, 8. So the answer is 1 over 32. So So look, whenever you see this, you know it's the derivative. Either you're gonna just take the derivative of whatever's there, or you're gonna take the derivative and plug in the number. Remember the two definitions we had? The definition of f prime of x, but then we got f prime of a, where a is the number. That just means plug in that number into the derivative. So for example, the next quiz, I wouldn't be surprised if you saw this. Limit h approaches 0. Okay, let me think. Tangent pi over 3 plus h minus tangent pi over 3 all over h. That's the same problem as that. This is the definition of the derivative. What function are you taking the derivative of? You should look right there. What function? Tangent x. What is the derivative of tangent x? Have we memorized these yet? Secant squared x, but since there's a number there, you have to plug in that number. So if you plug in pi over 3, this is your answer, except you gotta simplify it, of course. So now you're gonna know your trig values. What is the secant of pi over 3? What is the cosine of pi over 3? 1/2, so flip it over. 2 squared, 4, so the answer is 4. This simply means you're computing the slope of the tangent line when x is pi over 3. All right, number 5. I think the worst part of this problem was the arithmetic. Okay, so find the points on the graph. Anytime they use the word points on the AP exam, that means you have to give an x coordinate and a y coordinate, where the tangent line is parallel to the x-axis. That means horizontal. That means we need the slope to be 0. So we take the derivative, and we want to know when is that equal to 0. So we factor it. And it factors very nicely. -4 plus 2. So when is this thing equal to 0? When x equals either 4 or -2, right? I guess if you want to put equal 0 there. But it says find the points. So you have to, these are just the x coordinates. Now you have to take these numbers and plug it back into the original. This is where some of you had issues. This one should come out to 0, and this one should come out to 108. These are your answers. All right, second page. Okay, we're making some algebra mistakes on this one. Here's your position. 2t cubed, 21t squared, 16t minus 7. I wouldn't be surprised if you see something involving this on the next quiz. So, part A, when is the particle moving to the left? Part B, when is it speeding up? Find the velocity when the acceleration is 0. You can answer all of these questions by simply computing the velocity and acceleration and making number lines. So the velocity is, take the derivative, factor out 6, and it factors very nicely. T minus 2, t minus 5. Make a number line. Oh, plus, minus, plus. All right, the acceleration is, I'm going to look at the top one because it's easier to take the derivative. 12t minus 42, factor out 6, and you get 2t minus 7. So if you make a number line for that, you're going to have 7 halves, and then plus minus. Okay, let's answer all the questions. A, when is the particle moving to the left? When the velocity is negative. So just look at the velocity number line right here. When is the velocity negative? Between 2 and 5. Okay, B, when is the particle speeding up? When the velocity and acceleration have the same sign. So look at these two number lines. Where do they have the same sign? between 2 and 7/2, because they're both negative, and then from 5 to infinity and beyond, because it's both positive there. Okay, find the velocity when the acceleration is 0. So here's the acceleration. What would make this 0? 7/2. So take that number and plug it into the velocity. Now, which one of these is probably the easiest? I notice a lot of people plugging into this one, but I think this one's the easiest. So the velocity at 7/2 is, look, 6 times. What is 7/2 minus 2? Isn't that 3/2? And then 7/2 minus 10/2 is negative 3/2. 2 goes into 6 3 times, so you just get negative 27/2. Boom. But it really doesn't matter which one you plug it into, you're going to get the same thing. Or you should get the same thing. And then part D, at t = 1, is the particle moving away or toward the origin? Explain. So just like the one in the homework, what do we need? We need to know the position and the velocity. So first you figure out the position. So if I plug in 1 into the position, what is that going to be? 2 minus 21 plus 60 minus 17. That's 62 minus 38, which is 24, which is positive. So that means the particle is to the right of the origin. Then, what is the velocity when t is 1? Plug it into the, doesn't matter which one you plug it in. Shall we plug it into the top one? So what is that? 66 minus 42, that comes out to, 24, which is positive. So if the particle is to the right of the origin, and then the velocity is positive, which means it's moving to the right, then is it moving away from the origin? So it's moving away because x of 1 is positive and b of 1 is positive. That's what you need to say. And then number 6, it's the same questions except you just do it on your calculator. I think only one person can got this question right, I think. X of t is equal to t to the 4 minus 8t cubed plus 21t squared minus 19t plus 7. For what values of the t is the particle speeding up? So we need to make a number line for the velocity and the acceleration. So velocity is 4t cubed minus 24t squared plus 42t minus 19. Graph that on your calculator and you make a number line for it. I'll do it down here. So the only time it crosses the x-axis is 0.896, and then it's above here and below there. And then to make a number line for the acceleration, you take the derivative, what is that, 12t squared minus 48t plus 42. Graph that on your calculator and look where it's above and below. So this is what I got. I got 1.293, 2.707. So it's above, below, above. So what did I ask? When is it speeding up? Now look at your number lines. Where do they have the same sign? Between 0.896 and 1.293, because they're both positive. That's it then, right? Wait. No. What about over here? They're both positive. So also 2.707 to infinity and beyond. That's your answer. You guys gotta get your number lines. And then, for what values of t is the particle's position equal to 4? This is just like the homework problem, yeah? So here, just make that 4. How do you solve any equation on your calculator? You make one side 0, so here, x to the 4 minus 8x cubed plus 21x squared minus 19x. If you bring the 4 over, it's going to be plus 3, right? So what you do is you graph this on your calculator and you see where it crosses the x-axis. And it's going to cross 4 times. I believe the graph looks like this. It's a fourth power thingy. So the thing passes through the x-axis 4 times. These are your 4 answers. You just gotta calculate the root every time. So the first one is 0.198. The second one is 1.555. The next one is 3, and the last one is 3.247. I'm not sure what happened, because I noticed quite a few people only had 3 answers. I'm not sure how that happened. Oh, so then, it's kind of hard to tell, that's why. Yeah, then you gotta zoom in, and you gotta do this. What do you call that? Unpinch, you gotta unpinch the thing. Anyway, that's exactly the kind of questions you get on the AP exam, on the multiple choice anyway. All right. So starting today, we are using our book for the assignments. So if you look at the assignment sheet here, next week we got a holiday. And do you guys even come to school on this day? Are you guys coming?
Some people are taking SAT.
Oh, some of you are taking SAT?
Yeah, usually it's
Interesting. Anyway, so here, look. We're gonna spend 2 days on 4.1 because this is super important. It's even more important than the product rule and the quotient rule. So again, we're just learning more rules for computing derivatives. We're gonna spend 2 days on 4.2. That should say 4.2. Oh, no, it's right there. That's the quiz. Okay, and then, we're only got 3 weeks left in the quarter. Okay, so what are we learning this section? We're gonna spend 2 days on it. What could possibly be so important? Well, it's called the chain rule. You might have heard your friends in BC Calculus talking about it.
We're not friends with them. Yeah.
Okay, so the chain rule. So remember the last trig homework? Remember you have to use the double angle identities to compute the derivative? You guys remember that problem?
Yeah.
Well, you don't have to do that anymore because of the chain rule. The chain rule makes it simple. So we already know if y equals sine x, we already know the derivative is cosine x, right? But if you have y equals sine 2x, so if you have like sine box, is the derivative just cosine box? Well, the answer is no, because that's why I gave you the problem. How come, Mr. Park? That's because of the chain rule. It doesn't work like that. And so if you had, but so remember you had to use a double angle identity to get it? Imagine if it was sine 3x. Do you guys remember how to get an identity for sine 3x?
No, not really.
Remember you go sine 2x plus x, it's crazy. So Mr. Park, what if it was 10x or something? What am I gonna do? Well, we use the chain rule. So here we go. Let me show you the chain rule. So here is the chain rule, and you need to memorize this definition now. If y equals f of g of x, in other words, you have like one function inside another function, then the derivative is simply f prime g of x times g prime of x. This is a chain rule. All you're going to do is use this over and over and over. So let me give you an example. In fact, let's do the one I just showed you. If y equals sine 2x, so what you have to determine is which one is f of x and which one is g of x. So this is why you guys were given these problems in Algebra 2 and Pre-Calculus. Okay. If I have two functions and I plug one into the other, what would give me this right here? What would f of x be? Because we want this to be f of g of x. So so f of g of x means whatever's here, you plug into here, and then you get this. So what would f of x be? Sine x. Now what would g of x be? 2x, right? Everybody see that? If you plug this into there, you get sine 2x. So now we can just follow the chain rule. So the derivative is f prime of g of x. Now what does that mean? That means you have to plug g of x into the derivative of f. So that means we need to compute the derivative of f. What is the derivative of f? What's the derivative of sine x? Cosine x. So I have to plug in g of x, which is this, into the derivative of f. So if I take this and plug it in there, what do you get? You get cosine 2x. But then, and here's the most important part of the chain rule, you gotta multiply by g prime of x. Well, if this is g of x here, what is g prime? 2. Hey, that's the answer we had on the homework, Mr. Park. That's right. I was trying to give you a preview of the chain rule before we got here, although probably, I'm sure you guys didn't think that's a chain rule. But what you should know is the derivative of sine box is not simply cosine box. You gotta multiply it by this. And you know what that is? That's the derivative of the box. So I just showed you how this formula works, but when you actually compute derivatives, I would say don't think like this. Just think like this. Sine box. So we know the derivative of sine x is cosine x, so the derivative of sine box is cosine box times the derivative of box. So anytime you have a box, in other words, the box is this thing right here. Right there, that's the box. You follow the same rules as regular derivatives, except you gotta multiply by the derivative of the box right there. That's the chain rule. So what we're gonna do now is we're just gonna look at a whole bunch of examples until we get it. And that's why we're gonna spend 2 days, and you're just gonna keep practicing the chain rule until you get it. This is like going back to Algebra 1. How did you get good at factoring? Because didn't you guys have to do dozens of problems? Mr. Park, I'm still not good at factoring. But that's what you have to do. You gotta do dozens of problems. All right, let's erase. Which means you have to know your derivatives. Okay, what are the only derivatives we know right here? We know the power rule, product rule, quotient rule, and the derivative of the 6 trig functions, right now, right? Okay, let's do this. How about x cubed, let's go 2x cubed plus 3x squared plus 5x plus 7 to the 4th power. Now, before we learned the chain rule, the only way that we could do this would be to multiply it out. Didn't we have a problem on the homework like that? Where you had to multiply it out? In fact, somebody came in to ask me a question about that. Yeah, but now, no need. Because what do I see? I see box to the 4th power. Right? Box to the 4th. So what's the rule I'm going to use here? The power rule. Okay, so just think of this as x, which is box. What is the derivative of box to the 4th power? 4 box. So here's the box. Don't even worry about what the box is. 4 box cubed, right? Just like the derivative of x to the 4th is 4x cubed, right? But then here's the chain rule. Then you need to multiply it by the derivative of the box. That's the g prime of x right there. The derivative of the box. Well, what's the derivative of this? 6x squared plus 6x plus 5. There you go, that's the derivative. Isn't that way better than multiplying it out? Some of you would have a difficult time multiplying that out, I would guess. You guys follow that? So, look, what's the power rule? Like if you have x to the 7th, the derivative is 7x to the 6th. Right? Okay. But what if this is not an x? What if it's like another function? Like sine x or cosine x or some e to the x, whatever? Then the derivative will be 7 box to the 6 times the derivative of box. But see, if the box is x, the derivative of the box would be 1, and then you get the same rule that we learned. That's why, did anybody look at the list of derivatives that I gave you? There's a list of derivatives. Okay, let's try to find that. It should be in your notes and things. Where should I go here? No?
I'm waiting.
Hello? What are you talking about? Reference? No. Maybe I didn't give it to you yet. Never mind. I didn't give it to you yet, so that's why you guys don't know. Anyway, I'm going to give you a list of derivatives. And that it's not going to have x in it. It's going to have u. So it's going to be like this. It's going to be like, here's y, and here's dy dx. Basically, this is a list of all the derivatives you got to know for the AP exam. So the first one is u to the nth power, the power rule. So how do you take the derivative of box to the n? N box to the n minus 1. Just like if that was x to the n. But because of the chain rule, then you got to multiply it by the derivative of the box, which is u prime. That's the way it's going to be listed on the list I give you. In fact, where should I put it? I'll put it somewhere on the thing. And this goes for everything that we learned. Okay, how about the sine box? What is the derivative of sine x? Cosine x. So is the derivative of sine box cosine box? No, you got to multiply by the derivative of the box. That's the chain rule. So all the rules that we learned, you got to multiply by the derivative of box. What about cosine box? What's the derivative of that? Is it just negative sine box? No, you got to multiply by the derivative of the box. That's the chain rule. You guys get it? Every single formula we learned, that's what you're going to have to do. What about tangent box? In fact, why don't we just do the whole darn list now? What's the derivative of tangent box? Is it just secant squared box? No, you got to multiply by the derivative of the box. Okay, what about cotangent? Is the derivative simply negative cosecant squared box? Come on, you know the answer already. It's no. You got to multiply by the derivative of box. Two more, and hopefully we get it by then. What's the derivative of secant box? Is it just secant box, tangent box?
No.
No, thank you. Multiply by the derivative of box. And finally, cosecant box. What's the derivative? Is it just negative cosecant box, cotangent box?
No.
Thank you. There you go. That's your list. Okay, let's just keep on doing examples until we get it. It's going to take us. Okay, new problem. How about the square root? Yes.
Oh, sorry, for the one above, do we not like do the same thing again for the thing cubed? Like,
Oh, no, because
just
see,
leave it?
what you have, your function that you have is box to the fourth, right here. See? Box to the fourth, yeah? So you just go 4 box cubed times the derivative of the box. So when you look at it, you got to ask yourself, what am I seeing? Am I seeing box to the n? Am I seeing sine box, cosine box? Or am I looking at a product? Or then you got to use product rule. Don't worry, we're going to get to those. Okay, square root of, okay, let me think. I don't want to make it exactly the same as the homework, but what the heck? Secant x plus tangent x. Okay, now what am I seeing here? I'm seeing box to the 1/2 power, right? Isn't square root the same thing as 1/2 power? Like that? And you should write it like that. So you can see the overriding rule is box to the half. So what's the derivative? Box to the half. Again, this is simply the power rule. So what? 1/2 box to the negative half, right? But then here's the chain rule. Times the derivative of the box. what's the derivative of the box? Well, you got term by term, because there's two terms, right? Secant x, tangent x. I'm assuming we know these six. And what's the derivative of tangent? Secant squared x. Okay, right there, you got 2 out of 4 points. Yeah, you gotta simplify it. Exactly. So 1/2. This is the part that, see, I can teach my dog how to do derivatives. It's just mechanical, you can practice it. But then, what about the algebra skills that you've learned over the last 3-4 years? That's the problem. What can I do with this? I can factor out a secant x. And then look, hey, this one and this one is the same thing, so when you multiply, you just add the exponents, right? I'll put the 1 there for your viewing pleasure. So your final answer is 1/2 secant x times secant x plus tangent x to the 1/2 power. Or if you want to put the square root sign, you can do that too. Right, remember? You multiply things, you add the exponents. In fact, if you're taking SAT, you better know that, because they guarantee they're going to test you on your rules for exponents. So you got to know when to add, multiply, and subtract exponents on the SAT. Okay, let's look at another one. Y equal cosine x to the 5th. Now, just like I told you before, I don't know if I told you this before, I'm not sure what I'm remembering, but whenever you see a trig function to a power, you want to write it like this. You know why? Because now I'm seeing box to the 5th power. That's the power rule. So how does the power rule work? How do you take the derivative of box to the 5th? 5 box to the 4 times the derivative of the box. So you just got to ask yourself, what's the derivative of cosine x? Negative sine x. And that one, there's really no exciting simplification going on there, so all you can do is put the minus sign in the front, right? So anytime you have a trig function to a power like this, write it like that so you can see that you got to use the power rule. Okay, we just got to keep on going. Y equal, okay, we're going to kick it up a notch already. 2x plus 3 to the 4th times 4x plus 1 to the 5th. Now, before we learn the chain rule, the only way we could take the derivative of this is to multiply it out, and that would be crazy. Okay, now what am I seeing here? Yeah, I'm seeing something times something. So that means you got to use the product rule. So same thing again, I mean, you see a product, use the product rule. You see a quotient, you use the quotient rule. If you see a power, use the power rule. It's not that difficult. So I see a product, so I got to use the product rule. Derivative of the first. So this is just like, this is the only problem we have. How do I take the derivative of this? What do I see? Box to the 4th. What's the derivative of box to the 4th? We've been doing several of these already. 4 box cubed times the derivative of the box. 2. That 2 is everything now. If you don't put the 2, if you don't multiply by derivative of box, you know what we call that, right? A fatal error, because you're not using the chain rule. Okay, there you go. Derivative of the first, now you leave the second one alone. Now you leave the first one alone, times the derivative of the second one. Now what do I see here? I see box to the 5th. How do you take the derivative of box to the 5th? Come on, that's, look, right there. We did box to the 5th right there. 5 box to the 4th times the derivative of the box. What's the derivative of the box right here? 4. And that's it. Okay, you got 2 out of 4 points. You want the rest? You gotta simplify it. That's right, by factoring. Because later on, like I told you, next chapter, we're gonna be making a number line. The only way you can make a number line is if it's all factored. Okay, what can be factored out? Look at the numbers. I see an 8 here, and I see a 20 there, so I can factor out a 4. I see a 2x plus 3 cubed there and a 2x plus 3 to the 4th, so I can factor out 2x plus 3 to the 3rd. And then here, I see 4x plus 1, so I can factor out 4x plus 1 to the... Yeah, you always factor out the smaller exponent. You guys know how to factor, right? I just don't know. Okay, now, what's left? This is the hard part. If I factor out this from that, what's left? 2, 4x plus 1. Hey, you guys are lucky these are whole number exponents. Just wait till we get to the fractional ones. I don't know if we're going to get there by today. Plus, if I factor this out from here, what's left? 5, right? 5. 5 times 2x plus 3 to the first. Now, you know how you can check your answer? Factoring is simply the reverse of the distributive property, you know. So if I take this thing and distribute it like this, do you get the original problem? That's how you check to see if you did it correctly. Okay, Mr. Park, can I finally leave my answer like this? No moose breath, because you gotta be able to simplify what's in the brackets here. So, multiplying it all out. Okay, here's your final answer. Times 18x plus 17. Boom, that's your final answer. Then next chapter, when we make a number line, what goes on the number line? Negative 3 halves, negative 1/4, and negative 17 over 18. But you have to put it in factored form to make a number line. So again, calculus, not that difficult to do. Algebra, I still have problems, Mr. Park. Okay, do you guys think you can handle one with fractional exponents?
Sure.
Well, let's just see. Let's see how good period 5 is. 5x plus 4. Okay, so that's x squared times the cube root of 5x plus 4. How do I take the derivative of that? Well, I see a product, so that means I gotta use the product rule. Now, if I were me, and I am me, I would change cube root to 1/3 power, because it's just simpler to take the derivative, right? Like that.
Yeah.
Okay, so I see a product. Everybody see a product? That means we're going to use the product rule. So derivative is derivative of the first, that's easy, 2x, leave the second one alone. Then you leave the first one alone, and then how do you take the derivative of this second one here? What do you see? Box to the 1/3. Box to the 1/3. How do you take the derivative of box to the 1/3? 1/3 box to the,
Derivative of box.
no wait, 1/3 box to the
Negative.
-2/3. You gotta be able to subtract 1 from the power now. Times the derivative of box, which is 5. See, that 5 is, that's the big points right there. Mr. Park, how come we don't do it with x squared? Shouldn't it be 2x times the derivative of x? It is.
1.
Yeah, look, the derivative of box squared is 2 box to the first times the derivative of box, which is 1. That's what I was saying before, but yeah. Exactly, it is. But when you multiply by 1, it's the same thing. Okay, that's good. That's 2 points. Can you get the next 2? Factor it. Okay. What can be factored out? I see let's look at the numbers first. I see a 2 and I see a 5/3. What can be factored out? Okay, I'll give you a hint. Whenever you have fractions, you should always factor out the least common denominator. Just like this. Okay, let's go back to algebra 1. 2/3 x plus 3/4. Didn't you guys learn to factor out a 1/12? What are you talking about? Go to your room. Do you guys ever go to your room?
No.
If your parents get mad at you, because in my day, we could go to your room. Because you guys want to be in your room.
Yeah.
Go pull weeds. Go walk up and down the stairs 10 times. No. Okay, anyway. Okay, if I, no, just watch. Please watch. I'm trying to teach you how to grow up.
Up and down that.
If I factor out a 112, which is the least common denominator, what's in the parentheses? Come on.
No.
112 times what will give you 2/3? Thank you, 8x plus 9. That's why you do it. So now you know you put negative 9/8 on the number line when you make it. So whenever you have fractions, you factor out the least common denominator so you don't have fractions in the thing there. Oh boy, this is okay. I'm used to teaching remedial math. Okay, so I see a 2 and I see a 5/3. What do I factor out after that lesson there? What's the least common denominator with 1? Okay, thank you, 1/3. Now I see an x here and an x squared.
X.
X, you factor out the smaller exponent, right? This is algebra 1, right? Okay, but here, every year, this is where students have the issue. I look at this and I look at that, so I can factor out a 5x plus 4 to the, time out. Wait, let me compose myself. You factor out the smaller exponent.
1/3. No, negative 2/3.
Thank you.
My bad.
Negative 2/3.
I see.
Does everybody understand that negative 2/3 is smaller than 1/3?
Yes.
Or do I have to show you the number line?
No, it's okay.
Last year I had to. That's okay, I'll show you. Okay, look, here's 1/3. See? Negative 2/3 is to the left of it.
Whoa.
Therefore, it's smaller. Oh, I get it now. Okay, but that's the least of your worries. What goes in the brackets? In other words, this times what will give you that? 6 times 5x plus 4 to the what power?
1.
Very good. It is to the 1 power. Very good. It is 1. And again, when you multiply things, you add the exponents. Does everybody see that? Because if it's 1, then negative 2/3 plus 1 is 1/3.
Yes, sir.
Okay, plus this times what will give you this? 5x. That was the easy one. All right, I'm done, Mr. Park. No, you're not.
Simplify.
You gotta simplify what's in the brackets. So if you multiply it out, what's that, 30x plus 24 plus 5x. So your final answer is, what is that, 35x plus 24. Boom, that's your answer. So when you make your number line, you got 0, negative 4/5, and negative 24 over 35 on your number line. So you tell me what's hard. Is calculus hard? No, not really. Mr. Park, I'm still having problems with algebra. Yeah, that's why.
What is that first term in the bracket?
6,
Or like, how did you get it?
because 1/3 times 6 is the 2 here, right? You remember the distributive property, this times this, gotta give you this first term. Don't worry, we're AB. We're gonna have very few problems with fractional exponents. We're AB. But we're also Iolani. You know what I mean? The reason why we get so good AP scores, well, I do, is because we train above the bar. If you train below the bar, and then you gotta jump over the bar at the real meet, what's gonna happen?
Lose.
No, sometimes you might get lucky, but do you wanna rely on luck? I don't. We train above the bar. Okay, the bell's gonna ring soon, yeah, I don't even know what time class ends, 9, 10?
Yeah, I think
Okay. Okay, so we're gonna spend 2 days on this. Now, I didn't teach you everything yet. Still got a little bit more to learn on the chain. We'll learn that tomorrow. All right. You're done.
Mhm. Yeah, it's lovely.